Let me welcome our next speaker, Laura Garrison. She's a PhD candidate in visualization at the University of Bergen and Medical Imaging and Visualization Center in Bergen-Nobe. So Laura was previously trained as a biomedical artist, really cool, and later joined our community as she was fascinated by the effectiveness of visualization. So her research focused on visual encoding and interaction method for biomedical data that can improve health literacy at multiple levels. So let us welcome Laura and hope we will enjoy the talk. The floor is yours.
Thank you. Thank you for inviting me to speak today. It's a little scary to follow after Drew, but I'll do my best. So this will be a bit of a practical talk that generalizes somewhat from Drew's workflow, and hopefully this will serve as a brief primer to share what I've learned so far in visualizing biomedical content for communication purposes, first as a biomedical artist and applied now to the visualization research process. So I'll step through a standard content creation pipeline, for example, making an illustration or even for a software application. And to be clear, this is a bit different from the standard visualization pipeline that many of you might know about, where you start with data acquisition. And with this pipeline, I'll discuss the factors that you can consider at each step to create a visualization that ultimately is hopefully more effective in meeting your communication goals. So just very briefly about me, some of this has already been introduced, but my background is not in computer science, it's in anatomy, physiology, and chemistry. And I'm a trained biomedical artist, and I like to call it scientific storytelling. And before coming to work on my PhD, I worked for 6 years in the medical education startup industry space. And so the focus of my PhD now is how we can apply visual encodings and interactions to better understand patterns or relationships in various biomedical processes. And the purpose of stepping through these next slides is to just give an overview of the main problems that I've researched so far and to give context for these examples that I'll be pulling from later. And so something that I think is important to keep in mind is whether your ultimate goal for the application or the research problem you're solving is in analysis or exploration, communication of this information is still a critical aspect to keep in mind. So the first research area that I will just briefly introduce is an application design study for magnetic resonance spectroscopy imaging data, or MRS data for short, because that's a mouthful. So this is a specific acquisition method that visualizes metabolites, and these are biochemicals in the body that help sustain life. We saw some of these in Drew's talk. So the problem we wanted to explore here was MRS data, and its typical form is unintuitive to interpret. You can see it here. And to identify meaningful patterns that researchers are ultimately more often interested in ratios, which existing tools had limited means of showing. And so our goal with this was to enable spectroscopy researchers to quickly find patterns of ratios in their data for all metabolites in the study, which is kind of what we came up with here. And I've included just a few sketches to show some of my thinking process for this. So another problem that we've looked at so far is high dimensional data analysis schemes we know can reduce the dimensionality of a data set to find patterns and just make it more easy to interact with. But a problem is that it can obfuscate patterns that are subtle and therefore possibly interesting for the analyst. So we developed this method called DIMLIFT, dimension lifting, which is a method for exploratory visual analysis of high dimensional data with an iterative dimensionality reduction approach with this core case study for clinical data. And so here our goal was to create an interface that enabled experts, for example, clinical researchers, to ask questions and find patterns in their high dimensional data. And this is a bit of a side note, but I want to highlight that this was a collaborative project with the Otto van Gericke University in Magdeburg with a wonderful PhD student named Juliana Müller, who I worked with for a solid year on this, and we had shared research interests and complementary skills. And this is something in the course of your PhD is an invaluable person to find, and it made the research process fun, exciting. So I think the school is a really excellent opportunity for us PhD students to connect with other people and see if we can get some really cool research projects going. So I hope others are keeping this in mind as they attend this week. The last research area that I've looked at so far is this empirical study for evaluating visualizations of biomedical processes for communication purposes. And so the problem that we have in this space is that we don't really know. We have heuristics for this, but we don't really know what aspects of a visualization are important for meeting a communication goal for different audiences. So we set out to try to make some inroads to finding this out. So this is in progress. We submitted it to Viz, fingers crossed. And so what I want to talk about next is that each of these research problems we explored follows the same general pipeline that I've learned as a medical artist and then as a project manager. But I think it's just as applicable to approaching especially problem-driven visualization research. And following this type of pipeline, it's structured, it helps keep me on track and to meet my end communication goal that I have for the visualization work that I'm doing. And I want to emphasize here that communication is something that I think about and that we should all think about throughout the entire pipeline and not just at the end. And so this pipeline roughly looks like this. You understand the area, define the problem, ideate through it, develop a concept further, and then hopefully at the end you validate it. This is not novel to artistic production, even though we use this a lot. These 5 steps might look familiar to those of you who know this design thinking methodology that's becoming really popular with software engineering. So the idea is, again, it's a structured process that's designed for you to keep your audience, your users in mind and what they need to ultimately get out of your visualization. So now we'll just go through these steps in more detail. And so the first phase, and this is probably the most important one because a lot of the work that you do hinges on how thoroughly that, in my case, how thoroughly I've done my homework. So, because you need to understand the problem before, at least for me, I could think too much about solving it. So it's a lot of legwork, it's a lot of research. Drew mentioned in his talk how much time he takes and the different types of data he looks at to understand the problem space before he starts animating things. So these are questions, some of the questions that you can ask yourself that are applicable again for any research study, whether it's domain specific application or if you're writing a new algorithm for something. So, what does the design space look like? So an example of the approach that I took for this is for this empirical study. For each topic of the biomedical process space that we chose to evaluate, this example is showing the metastasis topic that we were looking at. I conducted interviews with domain experts and medical illustrators to help understand the space of how this topic is generally visualized. This was in addition to reviewing literature and also looking at online galleries of medical illustration and animation agency firms and other research groups that study this. So it's this part actually for me is really fun. I enjoy it. So other things to look at too are what is established in this space and where are the gaps. So for example, with the Spectrum Mosaic project that I spoke about, I joined the spectroscopy research group here at Haukeland University Hospital in Bergen for close to a year. So I attended the weekly meetings. I actually went down to the scanner to observe and even got myself scanned, which is not fun if you have claustrophobia. I would not recommend. But doing this gave me a lot of informal and formal interview opportunities that helped me really understand what these data look like, why it's hard to interpret and to understand the pain points and what people actually needed from it. And with this, it's hard sometimes to get out of your comfort zone and talk with domain experts, but I think it does really help to do a lot of background reading beforehand to try to make sure you have a rough understanding of the topic and to try to learn the terms, and more importantly, just be yourself, be friendly, and that can go a long way with getting a conversation started. So after I've done the research and understand the space that I'm working in, I then try to clearly define the problem. So thinking about answering this question, what kind of story do I want to tell and for whom? So Drew's did an excellent job about talking about this a lot already. When I'm thinking about this, I use Heilmeyer's Catechism, and this is a recipe to evaluate proposals on large-scale projects. This is especially used in startups, but it's useful also for research for me to help scope my work. So some of the main ones that come out of this are, what problem are you trying to solve? Who are you solving it for? And this one's a big one. Why is it important? So how do you motivate the work that you're doing? And so An exercise that I try to do is write it out in brief, so I'm crystal clear on what it is I'm actually trying to do, because that will make, if I can communicate it in a probably a sort of long sentence, it'll probably be a more successful project, and I'll be able to articulate it better for the paper that I'll hopefully write for this. So a couple of examples. So Spectrum Mosaic is an interactive tool to help MRS researchers visually quantify metabolite ratios to identify interesting metabolite relationships for improved pathology recognition. So another example, DIMLIFT is an interactive approach that allows experts to create and explore dimensional bundles in high dimensional data to find subtle patterns and relationships for biomarker discovery. So the next step after this is a fun one. So the ideation phase is where I start experimenting. So sketching out concepts, flows, and this helps you keep in mind who you're doing this for, or it's important to keep in mind who you're doing this for. And sketching concepts doesn't necessarily have to look like drawing. Don't be terrified of drawing. If your stuff looks like crap, it's fine. You don't have to show it to that many people, so it's not a big deal. But this can also look like the process that we saw demonstrated in the D3 workshop yesterday, where he was going through his, like how he lays out concepts for a more complex visualization, like this upset example. So it can look like that if you're scared of drawing. But here the idea is to narrate, to iron out your narrative. So thinking about the flow of your visualization. So how is the user guided through your interface? So for example, we made loads of sketches here for DIMLIFT. They're not beautiful, but they did the job. So they helped us try to figure out how to plan how you'd access these different levels of this dimensional hierarchy that we were building out. And we shared these within a OneNote notebook. So it was easy to collaborate and sketch alongside each other. It's also an area where you can think about the mood or the emotions you want to convey. We saw this again with Drew's work, and also thinking about how close to the data source that you actually want to stay, and how much freedom do you have to abstract away from that data source. Here, if you're not afraid to show your sketches, it's really nice to share progress and ideas with stakeholders. So something that I did for the this empirical study was I tracked in a Notion notebook, the series of sketches that I was coming through, and it helps me to look back and see the history of what I'm doing. But I shared these sketches with the various experts that I interviewed and got their feedback, and then tracked it in this way. And it helped me course correct some ideas that I was doing that were not so great at the beginning, so I didn't have time wasted later by communicating something that wasn't actually solving the goal that I had. And then this last one isn't very sexy to talk about, but it's important because at the end of the day, we all would like to get our PhDs, is how much time do we have, and how many, what are the technology constraints that you have to work within? So try not to let that throttle creativity too much, but it's an important factor to keep in mind. Next is refining and finalizing your chosen idea with ongoing gut checks for yourself that you're not going off in another direction. So you can also be asking yourself in this phase too, are you on track? Can you deliver what you're actually setting out to do? Do you need to scale it back at all? Because again, you won't have anything to communicate if it's not done. So it's helpful to have it actually, to have something complete and figure out what your minimum viable product is. So these finishing touches from your initial ideation stage can look like, for example, an initial style sheet here that I had of the aneurysm sketches that I wanted to go with, one of which I refined here. And then one of the things we were thinking about on and off is if we wanted to add annotations to this. We ultimately decided not to, in favor of having animation. But also interactivity could be more in line with your goals. So it's something to, this animation interactivity thing is important to have discussed early on, but it's something that you can reevaluate and revisit here if you need to because of time technology constraints. So this last step is also incredibly important. And I think a lot of us get scared of this because it's hard to know how to do a proper evaluation. But it's an important skill, I think, for us to learn. And there's lots of good literature that can help you figure out how to do this properly if you need the help. So something here to figure out is, does my end product support my communication goal? So was all that work that you just put in actually effective? Hopefully it was. Can I have real people evaluate my visualization? So there might be other ways to evaluate it if you just do case studies against published work, but it's always nice with visualization studies to have real people actually look at this. So for example, for the SpectraMosaic study, we had 3 experts go through this in the Think Aloud protocol, and that was really helpful. They hadn't really interacted with the application before, so we had this unbiased view. For the dim lift problem, we had a combination of evaluations. We had 2 case studies from previously published work, and then also had 2 clinicians from the neuroscience cognitive domain look at this as well and give feedback again in this Think Aloud protocol. So this brings up the question, though, that we've tried to look at with our evaluation study is, what does an audience look for in a visualization? So it seems, at least from this, so this is a little Tableau visualization that I made just to try to understand the data a little bit better. But at least from these results, and again, this was a sort of preliminary study in this space, but we looked at expert and general audiences, and there does seem to be a difference in how they evaluate, particularly their bottom choices. So that means that people look for similar things in different audiences for like a really successful, strong visualization for a topic, but there are things that they also respond highly negatively to, and these are different. So with this study, we also, for this, looked at the keywords that they chose to describe their chosen visualizations, and also scores for things like accuracy. Accuracy is really important, as well as aesthetics and visual clarity. And so to wrap up this pipeline discussion, the main point that I hope I've communicated is that communication is important in the entire life cycle of your research. So it's not something that you just start thinking about at the end, when you're figuring out how to or where to share your visualization, or even when you're first putting together the sketches. It's good to think about it early and figure out what you actually want and who your users are. And this will help you avoid wasted time and make something that ultimately is more successful for both yourself and, again, for your target audience or target users. So in the remaining time, I'll share a few more specific tips that I use kind of throughout this pipeline that hopefully are useful for some of you. And in the Discord also for this, I'd love to hear what you guys use as well for any of these sort of areas. So first one, I wish these guys paid me, but they don't. So Notion is a project aggregator thing that I use for all of my research now. This is in addition to library managers like Mendeley and Zotero. So they actually have all these templates, and you can use this thesis planning template. And it just helps me keep organized, especially in this initial understanding phase. It's really critical for me to keep my thoughts organized, as these will help me in interviewing domain experts, to frame my research questions later, to brainstorm design concepts. So having this or another tool is really nice. And if you have an education account, it's free. So it's a cool tool. If you're struggling to identify what it really is that you're trying to do with your research and how to extract features from whatever problem it is you're developing, you could consider building out user stories. These are really popular in software engineering at the moment. This account is hilarious. It's shit user stories on Twitter, and it's useful for me, at least, to understand actually how to frame a user story well. The guy is sarcastic, but it's helpful, at least if you're struggling with how to frame these types of things. And this is a nice method because it helps you keep the user front and center. So if you're developing especially a design study or application study, this is kind of something you want to go with. It can help you flesh out your requirement section in your paper, for example. For the ideation phase, I mentioned sketching. We do this a lot in production art, and I think it's becoming more common in research. But the idea here is just you want to get all the bad ideas out as quickly as possible, and you can use a method like the 5 design sheet method to do this. So if you go with this, it's probably I don't know, most comfortable to use just pen and paper, because then the stakes feel a little bit lower, right? So you're not going to get focused on making something perfect. If you have a drawing tablet that you're excited about using, go for it. But here, you just want to get out the ideas and don't necessarily focus on something that looks great. So other tools that you can use, so these are, the next few examples are sort of these visual tricks that I've learned as a medical illustrator. So create a visual hierarchy of information with grids and frames. Libraries for like Bootstrap will do this for you. But you can take advantage of perception and convention. So for example, what direction does your target audience normally read in? So in this medical illustration that I created a few years ago, I wanted to first educate someone on the regional anatomy in this area. So I made this one big and I put it at the top. And then I wanted them to understand what the different types of hernias are that can occur within this region. So then I've got them aligned here and it's a grid. The other thing that's nice to do is try to think about things you can do to keep your viewer's eye within the frame. And so I put the circle around here. And so the way I've set up the illustration, you have this strong line here going down and then wrapping around through these. You could argue that this is pulling you out of the frame a little bit, but I have a strong line here pulling your eye back up into the space. So your eye kind of consistently stays in. So this is something to think about in interface design as well that I think would be applicable. Color, there's been a lot of talk about color this week. I don't want to spend too much time on it because there's going to be a whole talk dedicated to it later by someone who's far more of an expert than I am, but these are just a couple of additional tools that I like to use. But the main thing here is color can be difficult. It's easy to have a rainbow vomit situation on your screen. So try to stick to color palettes to keep your palette reduced in number. This is a rule that I just was reminded about from this Instagram post by a medical illustration team in the Netherlands called Biotic Art Lab. So this is the 60-30-10 rule. So if you're also into interior design, you might know about this. It's used often there, but the idea is that 60% of your canvas should be a primary color. It is often a neutral color, but doesn't have to be. 30% should be complementary, and then 10% should be accent. And that guarantees that your eye of your viewer will go to where you want them to go and not get too fatigued. And this is an example of this implemented in a medical illustration. And that brings me to the end. So thanks again to the organizers for inviting me to speak. And I'm happy to answer any questions, and hopefully we can get a nice discussion going in the Discord as well to share some more tips.
Thank you, Laura, for the really excellent, great talk. I really enjoyed it. I'm also interested in design when I was a kid, so it's very fascinating that you can combine research and your interest together. We have a couple of questions, which is very interesting. So the first one is, okay, Sutherland was asking, he's interested to know what software programs you use.
I guess it depends on what. For layouts and I use a lot of Adobe products, but I'm trying to get away from using those actually. So I use Photoshop and Illustrator often. For animation, I use After Effects. For 3D modeling, I use Maya and Blender as well. Blender's actually been really nice. And another tool that I've just heard about for doing interface like UX, UI layouts and vector design is Figma. And that's a web tool. And again, if you have an education account, it's free. So Figma is a really nice one to check out as an alternative to Illustrator, I'd say.
Cool. So we have next questions from An Chu. She wanted to know the retrieval and searching and tracking software method on previous sketch notes you mentioned.
Sorry, what was that?
The retrieval and searching and tracking software on previous sketch note.
OneNote?
Sketches, your sketches.
Oh, so the sketches I'm using, again, it's a combination of tools. So the one that I showed of the different parallel coordinates things was just with Microsoft OneNote, which I don't love, but Procreate, if you have an iPad, is really nice. And I think it's Paper 53 is another drawing application that's really nice, but honestly, just pen and paper is nice. And it's, again, it's a really low pressure way to get ideas down for sketches.
Okay, thanks a lot. Okay, and Bara Kozlikova she's asking, what is your opinion on the role of labels in visual communication in medicine? It's deeply rooted there, but can we replace them to a certain extent with intuitive animations, for example?
I think for that, it really depends on your audience and the context that they have going in. So if they don't know anything about the anatomy or the disease or whatever that you're trying to illustrate, it's helpful to have labels to give them something to grab onto that's familiar. But I would love to see us come up with a way to make things intuitive enough that we don't have to go so crazy with the labels. So even if it's something where you have some sort of interactive view where you don't have, you know, this thing where I've got like all of these labels all at once, you could have some sort of focused storytelling thing where it's just like, these are, if you care about the muscles, these are what they are. But if you only care about this particular area, then these are the labels there. So I think there's better and better ways to do that interactive tools have opened up quite a bit.
Thank you very much. I'm still searching for, there are a lot of pausing that they are thinking they got a very great talk, and I'm scrolling down to find out if there are certain questions. Oh, okay. Okay, this is an interesting question. So Deepak is asking, you have an illustration career. Could you elaborate on how did you decide to do a PhD?
It was mostly frustration because I was working at a company called BioDigital, and it's a wonderful company. But what we were doing was, let's see here. So a lot of this stuff. So I was the content director there. And so we were building all of these very, very custom models, usually starting from data. So we had CT scans or MR scans that we would reconstruct it, but then we would have to do a lot of artsy things to make them actually look good and look like this. And then for these types of things, you can only go so far with certain data that are accessible in a production pipeline. And so I wanted to come to do a PhD in computer science because I wanted to learn about tools and techniques that we can use to make this easier and to figure out what can be automated. And because I feel like just so much of what we do in this production art thing is kind of a bunch of one-off solutions. And I just wanted to learn more about what we can do to make this less painful for artists.
Great, thanks a lot. Okay, so we don't have any further questions, but I see people are still typing, so maybe I can have a quick one. Oh, okay, I lose your slide, but it's fine. Oh, now I also lose my questions. What did I wanted to ask? Okay, so practically, actually wanted to ask a question, but I suddenly forgot because of yes, because I was also interested in okay, now I figured it out. I was also interested in creating some illustration and wanted to be a designer when I was still young. So what do you think is still one of the big things? I mean, now we have a lot of tools that really help us to make illustration to a certain degree, but do you think there's still very big gap between machine generate illustration and hand manual generate illustration, or it's very close to replace of a human designer?
I mean, I think the gap's definitely closing, but I think there's still like I can still tell. I can always tell if something's been hand drawn or if it's been computer generated. There's just a natural looseness that you get with hand drawn illustrations that just we haven't achieved yet with computational methods, although it's definitely improved. But I think the other thing now, and again, there's research heading this direction, which I think is super exciting, is there's still a lot that the artist has to do to figure out what noise to filter out and what level of noise is appropriate to include and how to focus a story. So tools that help with generating a narrative, I think are not really there yet.
Cool. I think I should invite you to attend my future user study because we are
Awesome.
we actually wanted to elaborate a little bit on this direction. So
Cool.
I think we are running out of time. I see there are still a few questions popping up in the Discord chat. So I would like to invite you again to join Discord and try to answer the questions. And besides this, I would like to thank you all very much. Thank you, Laura, for the great talk. And I would like to close this section, and we will see each other again soon.
Thank you.
Thank you.